now when you talk about alkene, now what should come to your mind is what is double bond. So now whenever I see a straight chain or a ring carrying a double bond, what should come to your mind is what alkene you get. So if for example here we already stop here 1, 2, 3, 4, 5, 6, 7, and there's a double bond here. Now what should come to your mind, because there's a double bond here, we are talking about what alkene you get. So now what you are seeing here is called what skeletal what structure. Now skeletal structure means that it does not show what numbers of carbon atom and what on the hydrogen. Now each point represents what carbon atom here. So how many points do I have here? Here we have 1, 2, 3, 4, 5, 6, 7. 7. So mean that what you have what 7 carbon atom carry what a double bond here. So now before we start naming the alkene, now what I want to teach you is that you can translate something to a carbon chain you get. So each point represents what carbon atom. So now we have what 7 carbon atoms here, which is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You get. Now the double bond that will carbon number 2, 1, 2, carbon number 2, mean that this carbon atom is what carry what double bond here. Can you see that? Now, so how do you now start filling with the hydrogen? Now, one thing that should come to your mind is that each carbon atom must have 4 bonds. You get. So with what I've done here, mean that for this one to complete 4 bonds, you need what 4 hydrogen. Mean that this carbon atom, so it need what 3 hydrogen. Now for this guy to complete what the 4 bond, or for this carbon atom to have what the 4 bond, then you need what 3 more hydrogen. So here we have 3 hydrogen here, 1, 2, and what and 3. You get. Mean that now is now satisfy what the octet. Now what about this one here? This carbon atom is already having a double bond here and a single bond, so making the what 3 bonds. So how many hydrogen does it need? It need what 1 hydrogen. So yeah, now the hydrogen can either stay down or be at the top. You get that whichever way you want to place it. Same thing with this guy here. This one will go to about 2. Then it will go to about 2. Then I go to about 2. Then I go to about 2. And 3. You get. So this is what you want to put in mind. So you can convert this one here to what to this other form here. You get. Now another thing is that you can actually what like compare this one here. Now if you don't want to show the numbers of bond or the way the hydrogen are be placed on the carbon atom here, now you can actually what place in the condensed structure. Now in the sense that this carbon atom here is having how many hydrogen? 3 hydrogen, so it can be CH what 3, right? Now this one is having what 1 hydrogen, so it can be C what H. The double bond here. Here we have what H, right? Then here we have what CH2, 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 right? 1, 2, 3. CH2, CH2, CH2. Then here we have what CH3. So here we have 1, 2, 3, 4, 5, 6, 7. So this guy also the same thing with this guy, and this guy also the same thing with this guy here, right? Now you can still go further and we'll compress it. You get. So now if you want to show this one here, CH, how many CH do you have here? You have 3 of it. Now times you don't want to what show that there's a double bond here. So you can write like this CH3, CH, CH. Here we have CH2, then what 3, then what CH3. Now this one show that there's a double bond here, but it's not being shown. Then why this one here we have a CH2 3 times. That is mean. So this guy also the same thing with this guy, and this guy also the same thing with this guy. This guy also the same thing with this guy. And most times should not be given like this, it will not be given like this, not be given like this. Most times in the exam you sit like this, you say what? Give the nomenclature of what of this compound. So if you don't have what an idea of how to what to represent one to this guy and this guy to this guy to this guy to this guy, there's no way you're able to what to give the nomenclature. But sometimes few times you'll be given like this and you give like this. But as an organic chemistry student, now you should what get to what first NT what given in the exam. So you know how to translate the condensed structure to what to fully distilled structure to what to a skeletal structure. Do you get that? So now let's start what's naming them. So how do we name this one here? Now first and first, now let's give you what the parent name. The parent name is what 1, 2, 3, 4, 5, 6, 7. The parent name is going to be what heptene. Right? Remember, it's been derived from what? From the alkene, which is what? Heptene. Right? We heptene. Just that the A is being replaced by what? By E. This is the alkene. Here is what is the alkene. The alkene is what? Is the double bond. The alkene is what? Is a single bond. Do that. Another thing you want to understand is that the position of the double bond matters a lot. You get that? So now the position of the double bond must have the what? Lowest possible number. Now the good thing here is that I can start my number from here and I can start my number from here. Now if I start my number from here, 1, 2, 3, 4, 5. I have what? 5. So here going to be what? 5 what? heptene. You get 5 what? heptene. But if I start my number from here, 1, 2, going to be what? 2 what? heptene. You get. So now the correct one is going to be the one that have the lowest possible what number. So this is the wrong one. This is what is the right one. So that when you are naming a alkene, the first thing you want to do is that what? Take the longest continuous carbon chain that contain what the double bond, and number is showing that carbon double bond must have what lowest possible what number. So that's what we have done here. The carbon atom here is what is one kind of possible lowest possible number 1, 2. Carbon atom is what is one kind of what the double bond. So that's why it's called 2 what heptene. Now in some terms we are going to see it as what hept what 2 what in. So it's still correct. You get. So you can either do what 2 heptene or what hep2 in. That's correct. I saw that one here. Now I go to name it here. Now first thing first, so we want to take the what longest continuous carbon atom that contain what the double bond. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. 5. Right? So going to be what? Pentene. You're going to be what? Pentene. You get pentene. Now, but the position of the double bond matters a lot. Now, if you look at the chain here, from here to here is what is my parent chain. I have what 2 substituents. 2 substituents here. Here we have what a methyl and what a bromo. You get. Now, but since it comes to alkene, the double bond is what kind of what the word priority. Now, in saying that, therefore, you must what number is showing that the double bond must have what the lowest possible number, irrespective of the numbers of this guy. You get. So if you start from here 1, 2, 3, carbon number 3 is what kind of double bond. But if I start from here 1, 2, carbon number 2 is what kind of double bond, right? So I'm now going to what number is in favor of what of the double bond. Now the double bond, the carbon kind of double bond must have what lowest possible what number. So here going to be 1, 2, 3, 4, 5. You get. So the parent there is now going to be what the carbon kind double bond is what carbon number 2. So going to be what 2 what pentene. You get. So that this is what the parent name. Now come now for a methyl and a bromo. Now B will come before M in alphabetical order. You get. So that going to be what 4 what bromo. The what 4 what methyl. The what 2 what pentene. Now let me name it as what 4 bromo. 4 what methyl. Pent 2 what in. Now do I correct? You get that? So now this is what you want to understand here, right? So now one thing you must put in mind is that number and alphabet are separated by what hyphen here. So that's why we have now when you see there's only a hyphen between number and what alphabet. You get. Now look at another one. Look at this guy here. So now the first you want to do is what number is such a way that you must say what the longest chain continue with the double bond. Now when from here to here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have 9. Now but this chain here do not contain double bond. So but when you start from here, this is what carry double bond. So that is what you must start from here. Remember when you're naming alkene, now your double bond must have what the highest what priority. So you must do such a way that you must include what your double bond in the what naming, right? So if you start from here, there's no what double bond. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no double bond. So but if I start from here, for me to include what double bond. So here we have 1, 2, 3, 4, 5, 6, 7, 8. Although it's having 8 is more accurate than this other one here. Do you know that? So in the exam, you don't want to pick this one, rather you go and pick this guy here, right? So here we have 1, 2, 3, 4, 5, 6, 7, 8. 8. But from here to here, how many we have? 1, 2, 3, 4, 5, 6, 6. So now we have to take this other one here. Of course, the double bond must have the lowest possible number. So that my double bond must be what a carbon number what 1, 2, 3, 4, 5, 6, 7, and what 8. So here I have 3 substituents. Here I have this one here. Here I have this guy. Here I have this guy. So here we have 1, 2, 3. Now this one is called what? Propyl. Propyl. Here we have what? Bromo. And here we have what? Chloro. You get. Now for those of you who have not watched my complete video on nomenclature of the alkane, now because in my nomenclature of the alkane I actually dive into this one in details. So I will now you see it at the end of this video, or I will leave it at the link below at the or I will leave it at the description below so that you can watch out what to name what alkane. If you have watched a nomenclature of the alkane, this will be what very easy for you. So now how do you start naming them here? Now therefore you must write what the parent's name, right? So 1, 2, 3, 4, 5, 6, 7, 8. It's called what? Octane. 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 Now, but the position of double is that what coming about what 1. So it's going to be what 1 what octane. You get. Now, how many substituents you have here? Here you have 3 substituents. Now you must name them what in alphabetical what order. B become first C and C become before what P. So it's going to be what 4 bromo. Here we have 4 bromo. Then here we have what 6 what 6 what chloro. And here we have what 3 propyl. 3 what propyl. Right? 3 propyl. Then here we have what 1 octane. 1 what octane. You get. So that is the name of what of this guy here. Let's move over to cyclo compound. Now the difference between alkene and cycloalkane, because alkene is in a what straight chain, while is an open chain. Alkene is an open chain, while cycloalkane is what is a closed chain. So I talk about cycloalkane. Now let's move towards cycloalkane. Here we have this one here. Now because is in a ring, is not what cyclo. Right? How many carbon do you have here? 1, 2, 3, 4, 5. 5 with what? The double. You have to do what? Pentene. Now one of the difference between cycloalkene and alkene is that in cycloalkene anyway can be what my carbon 1. Do you get that? So in cycloalkene the 2 carbon atom carry double bond must be what my carbon 1. So either here is my carbon 1 or here is what my carbon 1. Okay, so that is one thing I want to put in mind when naming what cycloalkene. You get, but you don't have to put the position of what of double bond here. You get. So we're going to be with cycloalkene. If I have something like this, we're going to be what cyclo what hexane. Why? Because the carbon atom here we have 1, 2, 3, 4, 5, 6, 6. You get. So as far as in a ring, it's not going to be what cyclo. If I have something like this, now how many carbon atoms do you have here? 4 carbon atoms. So it's going to be what cyclobutene. You get. Now one thing I want you to understand is that now what I want you to understand is when you have something like this, A and B can either be my carbon 1. There's this one cannot be my carbon 1, here cannot be my carbon 1, here cannot be my carbon 1, here can't be my carbon 1. It's only A and B what must be what my carbon 1. You get. So understand stuff here, because this stuff is highly what confusing. So if I have something like this, B arrow. Now remember I tell you that either here or you can be what my carbon 1, right? Now as far as this point is now the what point carry what a source strength, automatically this already be what my carbon 1. So A is my carbon 1, B is what my carbon what 2. Do you get that? Now so the name is going to be what 1 bromo cyclohexene. So that what 1 bromo what cyclohexene. So what you want to put in mind is that now the two carbon atom, if one point is what is kind of a double bond. Now if one point is kind of source strength, that point become what my carbon what 1. You get. Now when you have something like this, so when you have something like this, how you want to do that? Now these 2 points are having what these 2 points, these 2 carbon atom carry double bond, are having what bromo and what methyl. Now the solution of that my carbon 1 because one will come before the other one. Now bromine comes first before what methyl. Now when it comes to what alphabetical order, so you're going to be what 1, 2, 3, 4, 5, what 6. You get so now going to be what 1 bromo, the what 2 what methyl, the what cyclo what hexene. You get. Now the main reason why it's in my carbon 1 because it's going to be what it comes first in alphabetical order. You get. Now what about if I have something like this? CH3. Good. What about if I have something like this? What will be the name? Now what you want here, I want you to understand that either here or you can do what my carbon 1. You get. So I want to write this in 2 times. Now if I should take here as my carbon 1, definitely here is going to be what my carbon 2. Right? So if you have my carbon 2, definitely here is going to be what my carbon 3, 4, and what 5, right? Now if I should take here as my carbon 1, 1, 2, 3, 4, 5. You get. Now you can see that when I start from here, the position of the methyl is what is carbon number 3. But when I start from here, the position of the methyl is carbon number 5. Now the carbon atom carry the source strength was at the lowest possible number. You get. So the name of this guy is going to be what 3 what methyl cyclopentene. Right? Why name of this guy is going to be what 5 methyl cyclopentene. So which is the most accurate? Now this one is the word correct one, this one is the word wrong one. So this is what you want to put in. It's how you want to name that. Now remember that either here or here can be what my carbon 1. You get. Now the mistake so many people will do is that they are going to start not from here. They start from here. Now look at what some people do here. Now I've seen now when I give my student this structure to name, now this is what they do here. Now they do something like this. B and here we have what CH2. Now majority of them will start from here 1, 2, 3, 4, 5, 6. Do that. They now name it as what 2 bromo 3 methyl cyclohexene. Now which is wrong. Now these 2 points either here or here can be what my carbon 1, right? But if one point is not coming what a substituent, that point automatically will become what my carbon what 1. So yes, now because here is kind of what a double bond. So because this carbon atom is kind of what the bromo, so it's going to be what carbon what 1. So if you have my carbon 1, definitely the other point will be what my carbon what 2. If you have my carbon 2, you're going to be what carbon 3, 4, 5, and what 6. Do you get that? So now the main reason is that those 2 points kind of double bond. But either be what my carbon 1 or what my carbon 2. But if a point in that if a carbon atom kind double is that kind is substituent, automatically that one will not be what my carbon what 1. So that is the reason why it's what here is my carbon 1. If you have my carbon 1, you're going to be what my carbon 2, 3, 4, 5, 6. Not this way here. Do you understand? So here is now going to be what 1 bromo. Here we have what 6 what ethyl, the what? Cyclohexene. You get? So these are to what you have to what name more what complex or structure. I believe you have enjoyed this video. I have understood what you have done when it comes to nomenclature of the alkene and what cycloalkane. If you understand and follow through this video to this time, please give it a like and subscribe to the channel if you have not done that, so that you are not going to miss out every other video content we drop, right? Thanks for staying to the end of this video. See you next time.